Welcome to NPTEL course on fractals and multifractal. In the previous lectures, we have seen how to construct the fractal interpolation function and what is the nature of their parameters, especially how the fractal interpolation function behaves with respect to the vertical scaling factor and the function the q, also how the vertically the function is behave we have analyzed. Also for the horizontal direction, by adjusting the Li, we have discussed how the fractal interpolation function is behaving. So in previous lecture we have discussed the pattern and behavior of the fractal interpolation function. We discussed especially for the linear functions. Now we are going to investigate how to generate new fractal interpolation functions. For that we are going to enter the new topic, calculus of fractal interpolation function. So this theorem tells how to generate new fractal interpolation function from the given set of data points. As we know, if the data points is given, by fixing the scaling factor one can generate the fractal interpolation function. Now once the fractal interpolation is generated, by using the same function, how to produce new fractal interpolation function, that we will discuss here. If f is the fractal interpolation function associated with the iterated function system x, Li and Fi, that means Wi equal to Li of x and Fi of x comma y. So there are here n minus 1 number of functions, therefore it is understood that this fractal interpolation is we are generating for the data with size n, that means I equal to 1 to n. Here we are taking the form of L and f is given here, the Li of x we are taking Ax plus Bi and Fi of x we are taking as alpha I times y plus Qi of x. This alpha I is the contraction of Li of x, this alpha I is contraction of Fi. Sorry, this alpha is the vertical scaling factor. Now for a given y1 cap, now we have the data x1, x2, xn corresponding with y1, y2, yn. In the sense we have the order tuple x1 comma y1 and x2 comma y2 and xn comma yn. This data is given. Now for a given y1 cap, define the integration of fractal interpolation as like this one. The indefinite integral is defined as y1 cap plus integral x1 to x f of t dt. That is, we are going to discuss the indefinite integral of the fractal interpolation function over the region x1 to xn. In this region we are going to discuss the integration of fractal interpolation function f. Then if you define the f cap like this one, then this f cap is also a fractal interpolation function corresponding to an IFS, this one, where I belongs to n minus 1, where for I equal to n minus 1, f I cap is defined here, there is no change in the Li of x, there is a change in Fi cap only. It is given here, the Fi cap is given by Ai alpha I of y plus Qi cap of x ai is given here and qi cap is given here. I think it is x plus 1 minus xi, not xi to xi minus 1, xi plus 1 minus xi. Then I cap is given here and the new points will be generated by using here. Now, you can observe original qi fi of x we are taking in the form of alpha I of y plus qi of x. Now, that alpha I is transferred to here when applying the integration and the qi of x will change to here, and we are this point we are given, that means we are fixing this y 1 cap, then remaining y 2 this one I plus 1, that means y cap of I plus 1 where I equal to 1 to n minus 1 will be generated by using this equation. Now, let us see. So, once this theorem is proved, then we can generate the new interpolation function through the given interpolation function for the given set of data points. Consider this is the definition how we defined the integral of the fractal interpolation function x1 to x f of t dt over the region x1 to xn. Then now we apply, instead of x we will apply Li of x. So, this term becomes y1 cap plus Li of x1, we are getting x1 instead of x we are replacing x, therefore, there is no change in the lower limit, upper limit Li of x f of t dt. Now, again here y1 cap, now we split this integral as x1 to xi, xi to Li of x f of t dt, the same thing. Then this term y, this term we can call it as yi cap, this term we can make it as yi cap, where this term is xi to Lix f of t dt, because each xi we are getting one result, therefore, it is called a yi cap for I equal to 1 to n. Now, in this second term we can use the change of variable, take t equal to Li of s, here we can take this t equal to Li of s, then Li of s is ai of s plus bi, then if you are taking the derivative, the dt is dt, one can get bi will become 0 ai into ds. Therefore, this integral xi to Li of x f of t becomes ai times integral xn x1 to x f of Li of s ds. While applying the change of variable, the lower limit becomes x1 and upper limit x. Then f cap of Li of x equal to yi, here this term becomes this term yi cap plus ai integral x1 to x f of Li of s ds. Now, this f is a fractal interpolation function for the given data set, therefore, it will satisfy the functional equation, that means f of Li of s, f is the fractal interpolation function, therefore, it will satisfy the functional equation f I, that means the self referential equation s comma f of s. Then what is the form of f I? It is alpha I times y q I of x. So, instead of x we can change s, then one can get alpha I of f of s plus q I of s, here f of s act like a y, then one can get this one. Now, instead of this term you can apply here, then it gives that yi cap plus the ai, while taking the derivative we are getting the constant, that is ai integral x1 to x, this term alpha I of f of s plus q I of s. Now here you can split the integral again, not split the summation. ai alpha I integral x1 to x f of x dx plus the ai integral x1 to x q I of s ds. Now after this, from the equation 1, that means here the definition of definite integral of the fractal interpolation. Now f cap of x equal to y1 cap plus integral x1 to x f of t dt. So here you can observe, if you are taking here y1 cap instead of yi cap, we can write f cap of x minus y1 cap equal to x1 to x f of t dt. From here, then f cap of x minus y1 can be written as like this one. Then you can apply here, apply on here, then one can get y I cap plus a I alpha I. Then this is this one, this term can be written as f cap of x minus y1 cap plus this term is remains change. Then again a I alpha of I f cap of x we can take out, then you can take combined remaining terms. So it is y I cap minus a I alpha I y1 cap, this term plus this term is same. Now this all this term we are going to take as q I cap of x. Initially we are taking q I cap of x as alpha I think there is no special case we have taken. We have taken not in the linear case. I think q I is the general form only we have taken, not a linear case. Now the q I cap is become like this one, y I cap minus a I alpha I y1 cap plus a I times integral x1 to x q I of s ds. Now we can assume this term as q I cap of x. Now this f cap of li of x is written in the form of this two term f cap of x plus q I of x. Therefore this one you can compare with f I of x comma y can be written as alpha I y plus q I of x. X comma y, you can compare these two equations. Now this can be written as, because f cap of li of x can be written as f I cap of x comma f cap of x. This f cap of x like this one. Therefore thus f satisfying this self referential equation, therefore it is the attractor of the iterated function system. So we can call, if this f is satisfying the self referential equation, we can call the f is a fractal interpolation function or fractals. Now this f cap is a fractal interpolation function. Now we need to check the continuity of the f cap. The continuity at the joining point we must check. For that, take x equal to xn, then find li of xn equal to xi plus 1 for x equal to xn, yes, li of xn equal to xi plus 1 for all the I, because li satisfying the endpoint condition. Then find what is f cap of xi plus 1. Then one can get f cap of xi plus 1 equals, as per the definition, y I cap plus a I alpha I here in the equation 2. Here you can check from this equation, you can get this one, f cap of xn minus y1 cap plus a I integral x1 to xn q I of s ds. It follows that this one equal to y I cap plus 1. So y I plus 1 cap this is equal to then yi plus this term ai alpha I, this equal to yn cap minus y1 cap plus ai time integral x1 to xn qi ds. Then we can take yi plus 1 minus yi this side, then we will get this one. Then we know that yi plus 1 can be written as in the form of y1 cap plus sum of y cap of k plus 1 minus y cap. So, one can get yi cap from here y1 cap, then here instead of y cap k plus 1 minus y cap, you can replace these terms. Then this term will becomes here in the summation. Then take I equal to n minus 1, then one can get the end point. Here we are getting yi plus 1, then here we are taking I equal to n minus 1, one can get the what is the nth term. So, nth term is y n cap is, if you are replacing I value as n minus 1 here, one can get the nth term. Then here you can observe that y n cap minus y 1 cap we can write here. Then the y n cap minus y 1 cap, if you are this term comes this side and take the y n cap minus y n outside, then one will get this one. Then y n cap, from this one you can find the y n cap, then y n cap equal to y 1 plus this term divided by this term, provided this need not be equal to, this is true, a sum of k equal to 1 to n minus 1 a k and alpha k should not be equal to 1, otherwise the denominator becomes 0, this is invalid. So, you can observe here we are finding the all the endpoints, and this the continuity at the joint yi must be satisfied since the antiderivative of f is continuous. Therefore, the continuous also satisfied. This function is the attractor and it passing through the, this is the attractor. For each xi we need to find the interpolating points, the new data points will be estimated by using this equation. Yn we can find this equation, y1 cap will be given and remaining y items from, that means y2 y3 up to y2 cap y3 cap up to yn minus 1 cap, this data points will be obtained by using this equation. So, the new data points we can generate by using this equation. So, this theorem says if f is a fractal interpolation function associated with the iterated function this one, if we defined the indefinite integral like this one, then this f cap is a new fractal interpolation function, it will generate the new data points like yi plus 1 cap and yn is estimated in the end. Now, let us discuss the example for this one. F be the fractal interpolation function passing through this data 0, 1 by 2, 3 by 4, 1 is given in the equal distance and these are the given. So, if you fix the alpha value, one can find the corresponding iterated function system. Here this iterated function system is obtaining by fixing the scaling factor as 3 by 4 in all the interval. So, here 0, 1 by 2, 3 by 4 and 1 unequal interval 0 to 1 by 4, 3 by 4 and 1. Now, the scaling factor is defined and the alpha I is taken as 3.4 and all the interval, then one can get this is the f1, f2, f3, and if you are applying the linear fractal affine fractal interpolation, one can get the remaining constants. Here fi of x obtained by using taking the qi of x as alpha I y plus qi of x, where qi of x is taken as Cix plus di. We know how to find all these parameters by using the formula. Here you can, only thing you need to take alpha as 3 by 4, then we get the 4 different iterated function system. Then one can verify that this iterated function system has the contraction factor, this iterated function system has the contraction factor 3 by 4, because comparison between 1 by 2 and 3 by 4, 3 by 4 is larger, here it is 3 by 4 and here it is, both are 3 by 4, the maximum is 3 by 4. If you are taking the maximum, it is 3 by 4. So, the Wi consisting of all this mapping will form the iterated function system. The contraction factor of this iterated function system is 3 by 4. Now, this is the given data. For this given data, if you take the alpha value as 3 by 4, then this iterated function system will generate the fractal interpolation like this one. Then what is the fractal, the integration of this fractal interpolation function f? So, this one, the graph of f cap passing through these data points, these data points will be obtained by using this formula. Here yn we can find and yi plus 1 cap we can find, or in the theorem the formula is given. By using this data point we can find the remaining point. We have to check, we have to take yn cap. Here yn cap is taken as 0, here one can take yn cap, we can take yn cap is taken as 0, remaining y2 cap, y3 cap and y4 cap is given here. That means the taking the integration will not affect the Li of x, it only affecting on the y direction. Therefore, for this new data points, these 4 data points will be approximated by the fractal interpolation generated by this 4 iterated function system along with the same Li of x. So, Li of x there is no changes, this 3 Li of x there is no change. Here contraction is 1 by 2, 1 by 2, 3 by 4. So, 1 by 2, 1 by 2 and 3 by 4 for L1, L2, L3. Here for new iterated functions f1 cap, f2 cap, f3 cap, the contraction factor are given here 3 by 8, 3 by 16 and 3 by 16. So, among, if you are comparing 1 by 2 with here and 1 by 2 with this factor and 1 by 2 with this factor, one can get the contraction factor of W1, W2, W3. Similarly, if you are taking maximum among this contraction factor, one can get the contraction factor of the iterated function system compressing Li of x and fi cap of x comma y as like we previously did. Now, the graph of both the function, this is the fractal graph of the fractal interpolation function for the given data set, and this is the integration of this fractal interpolation function, whereas this data, this graph passing through the given data set, whereas this integration is passing through this data set. Now, you can observe that if this is the f for a given data set and this is the f cap, then f and f cap is not passing through the same data points. You can observe that f and f cap is not passing through the same data set. This f we generated by using the given data set, whereas this f cap is taking the integration of this f and this f passing through the new data points, that new data points are obtained here. Then what is the changes in the contraction factor? 3 by 8, the contraction factor will change ai times alpha I. In the original system it is alpha I, here ai alpha I y qi cap of x. So, this is the difference between here we are taking fi of x comma y is alpha I of y plus qi of x, and here this fi cap of x comma y, which is equal, this is f cap ai alpha I of y cap plus qi cap. So, it will passing through the different set of points, then the contraction factor is ai alpha I. Obviously, we know that we are taking here the ai values are less than 1, alpha is less than 1 and greater than minus 1, and this ai is, with this ai comes from the li of x, aix plus bi. We know that ai equal to subinterval length over the whole interval length. It is always less than 1 and greater than 0. This quantity, if you are multiplying, again it is lies between the same interval. So, it will act as a vertical scaling factor for the integration of this fractal interpolation functions. So, from this lecture one can understand that how to generate new fractal interpolation function by taking the integration of one interpolation function associated with some given data. Thank you. One can refer this result in the Michael Bansley book written by, one can refer Fractal Everywhere book written by Professor M. Bansley. Thank you.